Hello friends, once again welcome back to Triple tutorial channel. In this video, we will see what will be the behavior of a transformer when it is subjected to load. That load can be resistive, inductive or capacitive. And in the previous video, we have seen the behavior of transformer under no load condition. So here we will discuss about the behavior under load condition or the behavior of a transformer on load conditions. Okay. Here in this diagram you can see a transformer which is having primary number of turns N1 and secondary number of turns N2, and E1 is the EMF induced in the primary side and E2 will be the EMF induced in the secondary side. And here the secondary side is kept open and supply voltage, that is V1, is applied to the primary side. That means this is the no load condition. We know that in no load condition what will happen? If V1 voltage is applied to the primary side, then no load current I0 will start flows through this. This will leads to the formation of EMF in this primary side and hence the flux in the core, and that flux will be represented here as phi. The direction of flux will be this. So this is the no load condition. Already we have seen this. So what will happen if we connect some load to the secondary side? We know that V1 is the voltage which is supplied to the primary side. Then E1 will induce in this primary side. No load current I0 will flow through the circuit. And at that time, if we connect some load to the secondary side, then the secondary current I2 will flow through the winding, and this will create some flux phi 2. And this flux phi 2 will be just opposite to that of the main flux phi. So this flux phi is flows through the core due to I0. So flux phi is due to I0 and phi 2 is the flux flows through the core in the opposite direction of the main flux phi due to I2. I2 means it is the current which flows through the winding, secondary winding, when it is subjected to load. Okay, and the phase angle of I2 and E2 will be mainly depends on the type of load which is connected to the primary side, secondary side. That can be resistive, inductive or capacitive. So when the flux phi 2 starts flows through this core and which opposes the main flux, that means we can say when the transformer is loaded, the flux created in the core will weaken, or we can say it will demagnetize the main flux, so that the strength of the flux, main flux phi, will decreases. This will lead to decrease the EMF in the primary side E1. Okay, when the phi 2 flows through this core in the opposite direction of the main flux, then the strength of the main flux phi will decreases, or phi 2 will demagnetize the main flux phi. Due to this demagnetization, EMF induced in the primary side will decrease. So this is the important point that we needed to remember. So E2 will decreases due to reduction in the main flux. So in order to restore the primary flux, or in order to restore the main flux, this winding will draw some additional current, and that current is represented here as I2 dash. So that we can say I2 dash is the load component of the primary. Okay. So due to this I2, some flux will again created in this core, and that flux due to I2 dash will be represented here as phi 2 dash, and this phi 2 dash will be just opposite to that of phi 2. That means we can say this phi 2 will completely neutralize or completely demagnetize by the flux phi 2 dash. Both of them are opposite with each other. That is, phi 2 dash will be in the opposite direction of phi 2, or phi 2 dash will be in the same direction of the main flux. So that the effect of phi 2 will completely vanish by the flux generated by I2 dash, current I2 dash in the primary winding, so that the net flux will be phi. So we can say that the net flux will be constant in the winding. In this diagram you can see that. Okay, the effect of phi 2 will opposes phi 2 dash, so that the resultant flux will be phi only. There will be no effect for phi 2 and phi 2 dash. Okay. So that we can say the net flux will be constant. So here we can see primary and secondary ampere turns will be equal. N2 I2 will be the secondary ampere turns, and N2 N1 I2 dash will be the primary ampere turns, and on equating both of them we will get I2 dash as K into I2. Here K is nothing but the transformation ratio, and K is equal to V2 by V1 or E2 by E1 or N2 by N1, or which is equal to I1 by I2. That is the transformation ratio. And we can say that the primary current I1 will be the vector sum of both no load component, no load current I0, and the load component of the primary, that is I2 dash. So I1 will be equal to root of I2 dash plus I0 the whole square, where I0 is nothing but the square root of I mu plus IW. That means magnetizing component and working component. I mu is nothing but which is equal to I0 sin phi 0, and IW will be the effect of what working component, which is equal to I0 cos phi 0. Already we have seen these components detail in the previous video. Okay, and this is the condition, or this is the behavior of the transformer under load condition. Okay, once again I would like to say, during the under no load condition, if we apply V1 to the primary side, then no load current I0 will flow through this primary winding, and this will create some flux phi, main flux in the core. And if we and EMF E1 will be induced in this primary side, and if we connect some load to the secondary side, whatever be the load, secondary current I2 will flow through this primary winding. That means E2 will induce in this secondary side. Due to this I2, some flux phi 2 will again flows through this core, and this flux phi 2 will just opposite to that of the main flux. That means the main flux will be demagnetized by the flux phi 2 which is produced by I2. Due to this weakening of the main flux, induced EMF in the primary side E1 will decreases below the supply voltage V1, then at that time the primary winding will try to draw some current in order to restore the main flux, and that current is I2 dash, and this I2 dash will create some flux phi 2 dash in this core, and this phi 2 dash will neutralize the flux produced by I2, that is phi 2. So phi 2 and phi 2 dash will be opposite with each other. Thereby we can say the net flux phi will exist. The flux phi will exist in this core, and the flux will be always constant in transformer. And we can say during when we connect any load to the side, the core loss or iron loss will be always constant. That depends on this flux. Based on these concepts, we can see here some phasor diagrams for resistive load, inductive load, and capacitive load. In these three diagrams, phi is taken as the reference, and under no load condition, no load current I0 will flow through the circuit. And if we connect some load to the circuit, here the load is resistive load, then what will happen? I2 will flow through the circuit. I2 will be in phase with E2 because this is the resistive load. Okay, so I2 will be in phase with E2, and we know that V1, E1 and E2, V2, they are 180 degree apart from each other, so that we can draw like this. And the secondary current, when the secondary current flows through this side, then what will happen? Flux phi 2 will create. This will finally leads to draw I2 dash. That is, I2 dash is the excess current that is drawn by the primary winding, so that in the primary side, primary current I1 will have two components, I2 dash and I0. So this will be the phasor diagram. For an inductive load, the induced EMF E2 and I2 is drawn here. Here, since it is inductive load, the I2 will lag the induced EMF E2 in the secondary side. And we know that I1 will have two components, I2 dash and I0. So the phasor diagram will be like this for an inductive load. And for a capacitive load, the current I2 will lead the E2 by phi 2 degree. So both the all things are drawn here. I2 will be the vector sum of I2 dash and I0. So I2 will be like this. So these are the major phasor diagrams for different loads when the transformer is under load condition. Okay, hope you like this video, and thank you.